Hi guys, welcome back to my channel Mechanical Engineering Made Easy with Neha Mishra, because it is actually easy. So guys, in this video we will study about the basic concept about equilibrium. What actually equilibrium is, about its physical significance, not just the statement but what its statement actually means. That we will study in this video. So guys, first of all, let's read the statement of equilibrium, what it says. So, according to internet definition, equilibrium is a condition where the resultant force or resultant couple acting on a force is zero. So friends, what it means, let us understand by taking an example. So friends, suppose there's an object and suppose we apply 5 Newton force here. Now what will happen? Because of this force, this block will move in upward direction. But if I'll apply again 5 Newton force in equal and opposite direction, now what will happen? This block will now remain in stable condition. Why? Because I have applied same force in equal and opposite direction. Now suppose again if I apply here 2 Newton force. Yes guys, now since 5 plus 2 is 7 Newton force is applied upwards, whereas only 5 Newton force is applied downwards. Now since 7 Newton force is greater, this block will again now start moving in upward direction. Now to stop this, again I will apply 2 Newton here. Now what will happen? Again I have 7 Newton force acting upwards and 7 Newton force acting on this block in the downward direction. Now again they both will balance each other and this block will remain in equilibrium condition or stable condition. Now suppose I apply here 7 Newton force. Now what will happen? This block will try to move in right side. Okay? Now suppose I apply here 3 Newton force. Now again since 7 is more, this block will move in right direction. Okay? Now suppose I now apply here 4 Newton force. See, I have not applied same force 7 Newton force but 3 Newton and 4 Newton. So summation of 3 and 4 is how much? 7. So again on the left side 7 Newton force is applied and on the right side 7 Newton force is applied. So again this block will be in equilibrium. So see here, what is happening is summation, if we take the summation fx, what it will be? Yes, summation fx will be 7 minus 3 minus 4, and how much it will be? 0. Again if we take summation fy, how much it will be? Yes, 5 plus 2 minus 5 minus 2. Again it has to be 0. Let us take one more example. Okay. Now in this same block we have this inclined force of 7 Newton. Now again due to this force this block will move here. Now to prevent that motion I have to apply equal force in opposite direction. Now again this block will become stable and it will not move. Yes. Now suppose I apply here 3 Newton of force. Okay. Now suppose I draw its component. Okay. Suppose this is theta, so this will be something 3 cos theta and this will be 3 sin theta. Okay. Now instead of applying this equal and opposite force, I am applying equal and opposite force for this component, which is 3 sin theta, and equal and opposite force for this component, that is 3 cos theta. So see guys, what I have done, instead of applying the same inclined force, I have applied the opposite force of its components. Now again if you do it summation fx and summation fy, they will come as 0 because this is stable and the forces in upward direction is equal to forces in downward direction. So in case of inclined force also, if your object is in equilibrium condition, if it is not moving, it means what? If you take its component in vertical and horizontal direction and you take its summation fx and summation fy, it has to be 0. Yes, it has to be 0. Only then your block will not move. Only if upward force is balancing the downward force and force in left direction are balanced by the force in the right direction, then your block is in equilibrium condition and it will not move. Understood? And since they both will be equal, your summation fx has to be 0 like in this condition, and your summation fy has to be 0 like in this condition. Okay? Now guys, see, if your summation fx is 0 and summation fy is also 0, what will be your resultant? Yes, what is the formula for resultant? It is summation fx square and summation fy square, summation of both. Now if any of these value is not 0, obviously your r will not be 0. But since both this value has to be 0 for equilibrium condition, your r is also 0 for equilibrium condition. Now see guys, this block is also not rotating in this direction or in this direction. Means what? Its movement is also 0. Movement means summation of movement is 0. Now because of this force, this block might move in this direction, but because of this force, it is balancing the block. Means what? Due to all the forces, your summation of movement is 0, such that this block is not actually moving in any direction. Not moving means not rotating in any direction. Hence your movement, summation of the movement is 0. Now because of this force you may get some movement, but because of the all combination of all the forces, the total movement is coming to be as 0. Okay? So this block is neither moving in any direction, left, right, upward or downwards, nor it is rotating. Hence it is in equilibrium condition. And what condition is required for this block to remain in equilibrium? It is summation fx has to be 0, summation fy has to be 0, and summation of movement has to be 0. Again, summation fx and fy has to be 0 means what? Your resultant has to be 0. Only and only then your object will remain in equilibrium. Understood guys? So guys, we just saw the 3 conditions for equilibrium. Summation fx 0, summation fy 0 and summation of movement is 0. Now guys, let us understand this by taking one physical example. Okay? Now suppose we have got this rod. Now if I will not hold this rod, what will happen? It will move down. Okay, it will fall down. Why is it falling down? Because of its own weight. And weight is what guys? Weight is a force. So guys, to prevent this rod by falling down, what am I doing? I am holding it like this. Now is it moving down? No. Now it is in stable condition. Why is it so? For that, we should first understand what all are the forces acting on this rod, because we know that for any object to be in equilibrium, the resultant has to be 0, and to find the resultant we should know what all are the forces which are acting on this rod. So guys, for every object, the very first force which acts is its own weight. So the very first force which is acting on this rod, see, suppose this is the rod which I have taken, is its weight force, and where it acts? At the centroid. So suppose this rod is of 5 Newton. So with this 5 Newton force, it is moving downwards. Yes. Now I am holding this rod, okay, and keeping it in equilibrium condition. So I am holding means what? I am holding by this ends, on this edges I am holding. So I am applying some upward force such that it is not falling down. Yes. Now guys, tell me what force am I applying to this rod such that this rod is not moving now? Can you tell me? Yes, obviously your summation Fy has to be 0 for this rod to be in equilibrium condition. Now if you find summation Fy, yes, suppose this is x and this is y. So if we do the summation of this, it will be x plus y minus phi equal to 0. It has to be 0 for it to be in equilibrium condition. So what we get from here, x plus phi has to be phi Newton. Means what? I have to apply here phi Newton such that this block is not moving downwards. Now to keep this block in equilibrium, I have to apply same phi Newton force. Yes, we just saw that. Now see guys, if this block is moving upward, means what? I am applying more than phi Newton. That's why this block is moving. But when your block is in equilibrium condition, my hands are applying force equal to this weight force such that it is not moving. Now see guys, if I take this two forces, if I take this two blocks, now what will happen? How much is the weight? How much is the weight force acting downwards? Phi plus phi, yes, 10 newtons. Okay, suppose I'll draw its diagram. Now we have got two blocks and the total of two blocks is 10 newton. Okay, now these blocks are moving down with 10 newton force, and now if I try to keep this block in equilibrium condition, how much my force should be? The summation of both these force has to be 10 newton. So my hands are now giving how much force? 10 newton, exactly 10 newton, such that these rods are not moving down. Okay, they are in equilibrium condition. Now one important thing here to note is, see, if I was holding just one block, my hands were giving phi Newton reaction force. Okay, this block was phi Newton, so my hands were giving phi Newton force. But when I take two rods, my hands are now giving how much force? 10 Newton force. So see guys, the weight force is not changing. The weight force is fixed here, phi Newton and phi Newton. But is the force given by my hands is fixed? When I hold only one rod, my hands are giving phi Newton. But when I am holding two rods, my hands are now giving 10 Newton. So force due to my hands are not fixed, but force due to these rods are fixed. So there's a difference. The force due to my hands actually depends how much force I apply to it. Yes, if I apply less force, it will give less force. Yes, if I'll apply more force to it, now my hands will give more force. Now at one particular time, what will happen if I apply more of these rods, suppose 10 to 12 rods, after some point my hands will not be able to give that much force. So at that point it will start moving downwards. So there's also some limit to the force which I can provide with this hand. Yes, so this different in this force, weight force and the force my hands are giving are actually known as active and reactive forces. So these blocks are actually giving the active forces, or you can also call as action, to which my hands are giving reaction or reactive force. Understood guys? Action or active force is given by these rods, and depending upon the action, I am giving the reaction, my hands are giving the reaction, which means my hands are giving the reactive force. So there are these two type of forces which are very important for equilibrium, which are active and reactive forces. See guys, you know about every action has equal and opposite reaction, which is Newton's third law. The same concept applies here. How much action in terms of force this rod will give, the same amount of reaction or force I will apply to make it in equilibrium condition. So this is exactly what active and reactive force means. So guys, we will study about these active and reactive forces in our next video, and we will study about it by taking an example, and we will make our concept absolutely clear about active forces and reactive forces. So do watch my next video about active forces and reactive forces, because it is very important to solve any problem of equilibrium condition. So guys, if you have gained any knowledge in this video, do like, share, subscribe and comment. Thank you. About its figni about its figni क्या बोल रहा हूँ मैं? और आएगा कि एंड आएगा? और नहीं आता है, और ही है।
ओके
ठीक है ना, उतना से क्या फर्क पड़ता है। पेज वेस्ट हो गया ना पूरा। 3 + 4 7 होता है ना।